Hello, welcome. It's so nice that you came in such a large number, and I hope my presentation will be something interesting and funny for you. So my topic today is microservices, as usual. In the past couple of years, I haven't really been talking anything else about, but this time it will be a bit different because these microservices things will be quite new and even smaller microservices than before. So So this is the title, going serverless and microservices, that was advertised, but it's actually fake. It's fake news because it's actually not at all serverless. So serverless is full of servers. Let's make it that way. And microservices is actually not at all. They are nanoservices. Since up until now we were talking about microservices all the way. Everybody knows what microservices are. Mainly we are talking about node.js here, but there are other technologies as well, .NET Core, Java, so whatever. So we know what microservices is in the sizing. We already worked with them. So in a sense, today we were talking about nanoservices. So where have we left? Yep. Okay, so where did we left last time? A couple of sessions ago, we were talking about actually exploding that monolith. So please forgive me my crappy animation here. Yeah, that was an explosion. It was the closest to an explosion I could get on my keynote. So the thing is that we actually managed to explode that nice monolith a couple of years ago already. So, but we have already nice, very nice, very tidy and smart, small human-sized microservices, right? So what we actually have is a microservice, is a simple thing, just a small piece of business logic that's all about microservices. And so we are happy, aren't we? Well, the thing is that I guess we are not so happy. There are a couple of things around microservices that we already pretty much felt. And this is about microservices are really not micro at all. So microservices is your work is micro, your business logic is micro there. So that's a small thing, but everything around that is actually not at all micro. So if you check on a microservice, a very typical Node.js microservice, which actually just has a couple of HTTP endpoints in them and does very limited things, but actually does work in a typical microservices environment where you have 30-some of these services and talking to each other and doing HTTP servers whatsoever. So this is totally not a simple micro thing if done right. So there's a couple of things you have to code against or you have to code around when you do a microservice. So this is actually what the customer really pays for, or this is actually what you can have on the task board as something sellable. All the things in blue are actually a necessity, which are very hard to sell. Sometimes you can sell them, but they are really infrastructure. They are things for that little yellow stuff to actually work, operate, and be robust, whatever. So you probably would say, yeah, this guy is insane because there's like invoking an HTTP services, invoking an HTTP endpoint. Why does it have a blue box there? That's very simple. You just put the request.get, right? So that's all. I would bet medium-sized money on that in this group, probably like 20% of you would really come up with a perfect way of invoking a HTTP endpoint in a cloud environment. Anybody of you actually wanna give it a try? So what would that take to actually correctly invoke from one service to another, just focusing on the HTTP? Anybody wanna give it a shot? No? All right. So yeah, let me just go ahead with that. So yeah, normally you would put there a request.get and then you would believe it's all there. No, actually, a proper HTTP request toward another service looks like that. The reason for that is because normally, at minimum, you would have to deal with like a minimum thing on timeouts, for example. So you have to handle request timeouts, which is just an extra. Also, you have to handle the thing with the cloud environment. So whenever you are getting a HTTP error in a cloud environment, that's totally valid. So an error in a cloud environment is part of the business, because maybe in that very moment, the upstream server was just reclaimed by AWS and being replaced with a new instance. So some sort of unavailabilities, some sort of errors are quite part of the business. And then you have to now do some sort of retrial logic based on the error you see. If it's just a simple name resolution error, that's pretty much AWS tricking with your Route 33 thing. So a couple of things are critical, a couple of other things aren't critical, and you have to deal with them. Also, you would say that implementing a simple service startup is easy, right? That you just pop in express.listen and it's done. No, the thing is that actually properly booting up a node.js service, which has multiple dependencies, for example, it's depending on a database, it's also using some messaging, it also features a REST endpoint. So that's actually having all the things gracefully starting up and tearing down, so that actually there's no request recycled while you do that, is quite a complicated stuff. It's not at all easy. All the other things are seemingly simple, but when you do it right, it's quite complex. Finding another microservice, so you are working with 30 of them, and knowing where is that actually at the moment is not very easy. That's the endpoint here. So where are we running now? Which environment is it? What's the exact location, the address of the other server? So it's a couple of things that you have to tackle with, and that's just finding an address. Also, these left and right things, actually operating your microservice, scaling, deploying, actually running it properly isn't quite easy. So, for example, to have a cool, perfect deploy experience, you have to work against a number of things. You have to build up a proper CI/CD stuff, which has rolling over capabilities, not very easy at all. So our microservice is actually very complicated. And imagine the whole things that we see here in blue, they were with us when we built monoliths, and they were the same size as in this case, just we had a huge yellow box in the middle. So actually it paid off. But now with microservices, we have these extra burdens on us, and we have to deal with them. All right, you can say, yeah, NPM module, reshare. So I guess everybody's seen real microservice environments. Nobody is really able to share those things correctly. So things are pretty much very stochastic. So every microservice could implement things totally differently. So what's actually the problem? Why are we in that situation that I outlined? And the thing is that this is, so what's wrong with it? You probably figured out it's the missing semicolons, probably. But actually, I have to tell, this is copied from npmjs.org. This is Express's own demo, which I'm quite happy that they finally omitted the semicolons. So even now the Express team is opting out. It's time to reevaluate your stance on it. Anyway, so what's wrong with it? There's actually everything is wrong with it. Yeah, this is, I would say this is the business logic here, right? So this is the important part. And for this important part, we actually boot up a total web server, which is living in a totally manageable, but living in an operating system process that we actually have to manage. So it's a lot of things. We also deal with some port numbers here. We are actually doing an order processing function. Why on earth do we have to deal with port numbers in that? So they are so far from each other. This is infrastructure, port 3000. Hello world is our business goal. So they are quite, it's a spaghetti code in the sense that it actually totally mixes infrastructure and business code. Plus, you are just bury yourself into a HTTP stack. So your code is now just HTTP accessible. So that's the wrong with it, that we actually build things for a specific protocol. We are just very, very keen on using the protocol, the HTTP protocol for everything, but it's actually just a way for transmitting your functionality or providing a way for your functionality to be invoked. It's just one simple way. And yeah, so that's actually the problem. We don't do it right. Actually, our microservice is responsible for too much. That's simple. It shouldn't be responsible for things that are actually out of the business use case scope. What I'm actually meaning here, that our application actually should not really deal with things like an operating system process. It's so not right that our business code, which is a microservice, is actually doing operating system stuff. They are how they are related. So it's actually not right, but we are used to it, so that's why we think it's right. Well, the good thing, or the good news, is that actually a couple of other guys, I believe, was not happy with this approach. So serverless and functional microservices came to the existence like a year and a half ago. It was actually a byproduct. So 2 years ago, AWS figured out it would be nice to have a trigger-like mechanism whenever you upload something to S3. It would be so nice to have some logic that's actually linked to that, triggered by the upload, and then you could simply and easily run some little code when you upload a file. That was the original concept. And a year later, the serverless infrastructure and the approach was born or coined. It was not very far away from now, like a little bit more than a year ago. And now we have very comprehensive serverless approaches. So what's the proposition here? The proposition here that we should really build simpler microservices. I mean, literally very simple things. It should be like this. So instead of what's actually, when we are creating a microservice, what's our interface toward the world? Yeah, our interface is probably some REST API, a HTTP core, a socket, or something complicated thing. Or a message queue or something. But what if our services were actually that simple stuff like a function? So why is a function better than anything else? Well, because it's very straightforward how to work with it. It's very simple and it's very straightforward. You just have to invoke it like a function. So function invocation is, I guess, first we learn speaking, then reading, then invoking a function as JavaScript developers, right? So so invoking a function is quite natural stuff. It's like the basics of programming. So if our services were actually just that simple thing, then what would happen? Probably everything would be easier or simpler. Just because we don't have to deal with anything else than properly writing a function. I guess we are way more capable on properly creating a function than actually building a complete web hosting solution, which is a microservice. A microservice is a web hosting solution. So this is quite simple stuff, but of course it will have a price. So let me show this in action. So the new smallest part or smallest possible service unit is a simple function, and what we will do here is just putting together a very simple function at AWS that you see how it's actually done. Let's just do a hello world. And what we are seeing here is just very typical. There will be slides about that, but we are actually creating now a function, and we are, if we want to, could define some trigger for it. Like a trigger is a HTTP request as well. We will see how it's actually decoupled, but what we will do now is just really build one simple service. And CorpJS. Yeah, so this is the simplest possible service and function we create. So this is our handler. Let me clean it up. But the thing is that that's the whole thing. That's the whole service. Just one simple function. All right, I'm not able to delete this. Yep. So this is now a functional service, if I might say, and I'm able to run it. So this is just test payload, and what I'm saying is that it has been executed by the AWS runtime actually, and actually I've built a functional microservice which does very little, but I had to do very little to achieve that. So what I did is just return some values, and the service became functional. So that simplicity is actually the basis for most of the good stuff that comes out from serverless. So let's see what is the serverless application concept. So serverless, strangely, has quite a big understanding on what a serverless architecture is, without having any kind of standardization. So everybody knows that, what I mean, everybody who is now servicing or providing something for the serverless market, everybody knows that these are the basic blocks that a functional or serverless environment needs to have. And these are pretty much the things that we were battling with when we had a full-blown node.js microservice. So in a serverless environment, we have an abstract about events, record stores, roles, tags. These will have sort of implementations in any cloud environment, but we will see the same sort of things in most of the environments that we will study. So these basics are there in AWS, there in Google Cloud. Yeah, so these building blocks or primitives are the tool set for us to build actually great applications. How are they supposed to work? Yeah, that's clear. So everything, that's an important thing. Everything, these are very simple things. The whole concept about serverless is you have very simple building blocks, but there's one very complicated things around that. And that's a serverless platform. So all the magic that I'm showing today is actually possible because there's a serverless or functional platform underneath us, and actually constructing or building such a serverless platform is a very complicated matter. All right. So what's the serverless programming model, and how are we supposed to actually build things inside the serverless environment? So it's very straightforward. There are things that fire off events. These are very basic stuff. I mean, event is just an object, a hash of information. That's an event. Things fire off such events, and we are able to bind functions that very simple, couple of parameter, simple callback like functions to them, and do stuff. The do stuff part which is the most complicated, I guess, on the backend side. For a serverless environment, for our serverless stateless functions, what we need is endless backends. I'm telling you why. Endless backend is that they scale on an arbitrary manner, and we don't have to deal with them. So these endless backends are the key in actually having a serverless application, because here, where the magic happens, you don't deal with anything about scalability or accessibility. So functions, in that sense, are very simple stuff, just really invocable functions. But the great stuff in it, that everything regarding the function invocation is done by the serverless environment. So what we do is build up a function, and we will be invoked. We will be invoked on a level of parallelism that we are requiring. This is a very hard to achieve thing, or was very hard to achieve. So this kind of free easy scalability is very hard when you have to manage it with operating system processes. So what's scalability on that part? What do you do there? You fire up a new machine, fire up new node processes. You need to manage that kind of scales, stepping and scaling up and down. So you have to do complex things, and even there will be those bumps when the new scaling unit kicks in. So that scalability is very complicated. Functions, however, very, very easy to understand. They are still executing. So what the serverless operating system around us does is that while a function of ours is executing and a new request comes in, it just fires off a new function, a new instance of the running function. So it's inherently scalable because the scaling piece is very simple. All you have to do is just start another function if one is still executing. This is way more simpler than listening on load statistics of the process, seeing when the memory is going off, that sort of thing. It's quite easy to achieve. What is not so easy to achieve is having things that are able to pick this up. So these endless backend things, which are the key, as I said, is the make or break part of a serverless infrastructure. That's why it's not very easy to build your serverless infrastructure at home, because probably that part will not be easily achieved. Just a second. Yeah, all right. Just one more thing. Your functions, which are invoked by a number of events. So what kind of event we are talking about? Literally every kind of event. Whatever happens in your environment can be a trigger for a function. The typical one is a web request comes in. So REST request arrives and you have to handle it. The thing is that you are not anymore coding against HTTP. The thing is quite simpler. You just create a function and then somewhere later you say that for a specific HTTP request, let's run that function. Or whenever a data record changes, let's run another function. So this kind of event-driven programming model, which is not a linear in that sense, is just a simpler way to actually deal with complex applications. Your building blocks are operating on the same manner. Everything produces an event, you are getting invoked, your function gets called, and then you do something which eventually does two things. You probably store some data somewhere or fire off an event. The data is persisted, but that fires off another trigger, so the whole story can continue on. So you can build up quite nice processing pipeline just with simple method invocation and firing an event. How it in the reality works, this is one of the web application, one of the workflows the serverless system supports. It's just a simple single page application. The way it works is that there is some very not smart files stored in a file system, like a blob store, S3. So what you do is here is just you have files. It loads up into the user's browser, and the user's browser will engage our serverless environment using simple AJAX requests. What happens? It gets into the API gateway, it might run over some authorization. Anyway, your function gets invoked, and the function result gets back here. Very simple. Typically, this is said to be serverless because you really, when you build such a system, you really don't deal with any kind of service. You don't start any servers or you don't do any such of things. You just upload some files to a file store and you upload some functions to a function store, and that's it. Everything else is taken care of. That's one sort of synchronous workflow. And the other typical is the asynchronous workflow. Something is uploaded, like a file. The user uploads a file, a big binary file, toward your blob store. An event is generated. Your service checks some viruses and then spam, whatever things, and then fires of a data change. Another service function is, however, able to peek into the database. So what happens? This is the asynchronous serverless flow on, well, not just serverless, it's the asynchronous flow. The first operation returns you a token, and with the token you can just view the database. Is my image processed? Is it there? That sort of thing. The important part in this and the previous one is that all you have to really care with the yellow boxes. The other things are really managed outside of you. So I told you that all this magic is just really possible because we have a good serverless platform. We have a good function as a service platform underneath or with us. How is actually or what is a good serverless platform, and what are the actual attributes of such a platform? There's one simple definition which I found on web. So you can say that your platform, that your environment is sort of serverless if it's able to spin up or start a process which will run just 15 milliseconds in less than 30 milliseconds. So if you are able to fire off processes that fast, which will run just really fast in less time, or which will run just a couple of milliseconds, then your system could be considered a functional service environment. This is quite important, starting off a process fast, because that's the key trick in serverless, in functional. As I told, the system is the way all the scalability magic is done is that if your function is currently executing, let's spin off a new function and start that. It's very simple to do if you are able to do this sort of not very easy stuff, starting off a process in that fast. So that's a minimum. Also, or just as a basic, most or all serverless platform provides you with some very cool way to provision things in it. So you will be able to deploy new functions, new stuff in a variety of ways, with a command line interface, with some big configuration payload. So you will be able to just actually have things there with a little effort, not like installing and starting and deploying a total node.js environment, just by simply uploading a file and making that as a function. There are cool command line tools for that. It's basic. Stacks in a functional environment are super important, as we will see, because we will have several hundred items, and these stacks are the actually the bucket, the big sack that we actually use to put everything in it, and then we can deal with all our tiny items as one whole. So actually a stack will be an environment, we'll see. Yep, and maybe one quite important thing is functional environments support the possibility or the feature for you to change a number of things in an atomic or in an unbreakable way. This is important because when you are deploying your functional system, which will have like several hundred items, you don't want that system to be online when it's just half there, so when it's not fully installed. However, some of the installation fails and then you are there in a half-baked state, so the ability for only make your changes or put your changes to real live, when everything is done, is a key attribute for a serverless platform. It's again not very easy to achieve. But we actually, on the other hand, do put a lot of energy when we do that with Node.js. We have very complicated CI/CD environments and Kubernetes, and we know how to do that. But that's actually the very same thing, just done not by us, but someone else in a little bit better way. So if you have these things in your environment, you already have a functional environment, which I would doubt, because there's not a lot of on-premise version. And yeah. And if you have, another characteristic, because of this sort of endless backend thing and easy scalability, this is how, for example, AWS Lambda scales. What you see here is a sort of a linear scaling from 1 request per minute to 80 requests per second. It's a very lengthy operation. What's happening in the background of this chart, I haven't done it, someone else did, is about 400 long hash calculation thing. What we see here is actually a linear performance. So we actually double, triple, quadruple up the number of requests, but we see no real degradation in performance. So that's actually the funniest thing in serverless. You don't really deal with any of those scalability things. And who are the providers, or who can you use now for such a serverless session or experiment? So actually most of the big cloud providers have some offerings, and most of them is quite new. Like the oldest is a year old. AWS is obviously the deepest solution now, and they probably was the first to start the whole thing. So they quite provide everything that you could imagine, even doing serverless, asynchronous, whatever functions when you commit a line of code. So everything is integrated into their serverless platform, all the best, and this is what we see in AWS Lambda. Azure has some offering. It's quite new. The biggest advantage over the others is what they provide budget capped versus a scale on demand scheme, and this is very important. Most of the functional services will scale to whatever size is, and that's the risk. So if you happen to create a nice website which like lures in a lot of people, you will pay a lot for that. So it can jump to like well, not to the sky. It's very cheap, by the way. So running a function is like a fraction of a millionth of $1, but you actually will have a lot of functional cost. However, the Azure solution here is that you actually put something that will keep the whole auto-scaling, and the thing will be not so fast, but actually you will still have money next day, which is very important. At Google, I don't really know a lot about them. I tried to, it's very new, nothing special I found there, but Google is cool. So why not have them here? Probably they will be very cool when they are ready, but now it's very limited. So it's in beta, and you can have 20 functions, which is nothing. And there's then IBM offering, oh, sorry, this is one word, actually, it's OpenWhisk. And that's a funny stuff, because that's the only solution that you actually can run in your environment. And that's very, very important for functional services. You will want them run locally, and now only OpenWhisk provides you the very same environment locally than online. It's cool.
Yeah, but in the case of OpenWhisk, you have also the operation cost.
Yeah.
What you mean in that case, it's a good question.
How do you mean the operation cost part? Or the other has operation costs?
You have to manage the servers.
Oh yeah, when you run locally, yeah, definitely. Local run for me is mostly important because of development time. So that's whenever functional, you probably already have to be cloud bound. That's probably basically now the minimum that you actually probably have to run on some of the big guys' cloud. But having an on-prem solution is really to have local test times, on the move or on the go environment, which is very important. Otherwise, you are unable to work on the tube, on the train. So yeah, and it's some do work a lot on trains. One thing here, and then I really jump in showing some more code, is there's a big distinction that we have to make between serverless and serverless. Serverless is a library, while serverless is a platform. And the serverless library is a very good choice for a name, but they do is actually providing you a little bit simpler serverless thing than otherwise. So let me show serverless in action. Not really in action, but how you can actually imagine the thing. And what I'm now showing you is a real productional functional microservice environment that we built for a customer. Not sure. A lot of things you will see, but probably yeah. So these are just simple JavaScript files, not a real complication in them, and most of them is about concluding. Should I find it? Yeah. This is not the best. Maybe this one. Yeah. So this is what we're seeing. This is just really those top-level enterprises are just producing a function. What they do, nothing else, producing a function and doing some logic inside. What serverless is here for is that you can build all your environment, all those several hundred items that I was talking about when I said it will explode to tiny pieces, into a big, nice configuration file. It's like huge, it's the biggest. Because you will have to configure a lot of things in a serverless environment. So what serverless provides you is a way for you to write down all your things that you have. So this is how you introduce a function, have them in one huge file, and then it will crunch it and process it, and it will do some things in it. At the end of the day, you will have a built-up AWS environment with, in this application, we have 50-ish number of functions, and we are having more than 500 artifacts or entities. Because we will have entities for permissions, log routes, log rows, there's a lot of things. So what happens here is that a very non-big application, so this is just a simple front-end tool for a database, not a huge undertaking. It will have a lot of things to configure. So that's actually the price for the magic, that you will have this sort of tiny things that you will have to take care about. And now this is actually the best tool on the market, is that you build up this huge file. I will totally understand if you are saying it's not cool. Oh, so yeah, this is less cool. But this is how actually serverless now works. You will have to produce and survive those huge files. Otherwise, actually the magic isn't happening. Now, serverless is just a cool abstraction over the real thing. Let me show you that. Because the real thing is the AWS CloudFormation template that will build up the whole magic in AWS. So that was, the previous one was just a very compact version of it, and now here is the real thing. Yeah. Alright, so this is a 50 or 20 function service. Yeah, right. It's still happening and happening and happening. So this is like insane. That's a negative part. That's the hard part in serverless, that you will have this whole thing. All these, if you install online, let me show, will look like this. Let me show the application. Alright, so this is just a functional list. These are the functions that we work in. Alright, so those are the services inside. If we see the whole stack, and we will see it's huge. So this is the list of resources building up a very simple, there's more, a very simple couple of function applications. There's a lot of things around. So it's not free. The serverless magic, that you just write a function and it just scales itself, works, whatever, it's not free. You have to manage this part, but otherwise everything else is taken care of, which is quite good. Or, and let me just, I'm really going on a closure soon, just here is where the actual interesting things come. So, yeah. There's a couple of caveats around serverless, but the most problematic part is that you probably have to decide or dedicate yourself for a cloud provider, because, as I said, serverless is actually now happens in a cloud. It will lock you in that specific vendor. You will have configuration files, and there are a couple of things that the whole thing is not good for. For example, WebSockets or something that needs real state is not for functional services. However, stateful programming is a bad idea anyway. So I'm not saying sessions, just stateful programming. So the whole thing with functional is about keeping the good functional practices, which is a function should be pure, it shouldn't have real side effects, it shouldn't have state, because it's easier to maintain. And the cool things that it will scale, it will have a very easy deployment mechanism once you survive those files, okay? It forces you to adopt some good patterns. Let's not go into that, but the really important is that with serverless, you can actually get something into the magic part. So you can do magical things because of serverless. Actually, because all your things are now just functions. If you can say that, so the environment you are building is actually just functions, you are able to do a couple of funny things. Let me show. What we built up in a couple of days, so just as a proof of concept, is a very simple way to infer all this horrible configuration thing from actual natural JavaScript code usage. So why would we want to build a huge configuration file that describes all the things if we are able to express this idiomatically, not using anything else, just the language itself? Why wouldn't we want to do that? And we built a little framework around AWS CLI and other things. So what we came up with is a way is that just by simple language tools, you are able to define a function very simply. So what we see here is just a hello world function, and this would be the same as the express example, all right? So this is a very simple function, but what we do is already we will take some parameters. So here, the whole code I needed to do is just define the function and add some information to this. It now uses some techniques like subclassing and also attributes or decorators. But the thing now is that with this very simple setup, I'm able to do a number of things. First of all, I'm able to publish this to AWS. Just here. So what it does, it compiles, it actually involves some Webpack as well, because serverless environments aren't really smart, so what you have there is just your file structure. You cannot run an npm install there, so you will have to compact everything. And with this simple statement, I actually had my hello world function deployed, so this is where I deploy this, and I'm able to invoke it. So if I'm invoking, this is the invocation. What I'm using, if you see, what I'm using here is AWS command line tools to just invoke that newly installed service, which is called hello world, and I'm submitting some data to this. And yep, I did invoke this, and actually had an output of hello in a result me, which was actually the parameter coming in. And so what's happening here is there's a couple of magical things. We just decoupled ourselves from the AWS way of having a serverless, a functional service, a serverless thing. We just decoupled ourselves, and we are having a quite abstract function signature, which will accept whatever parameters we want using decorators. So here we got rid of how AWS passes information to us. We just pull in information as we want, and because the whole invocation, because the whole functional service is very simple, we can wrap it around. So our service will be wrapped with some code that processes, pre-processes information, and digs things out for us. Also, we just could implement the async pattern this way. So because of the simplicity of the service itself, because it's a function, it's very simple to compose this function and use composed version of it. Now, let me show just another example which actually sheds a little bit more light on how it really excels. So, one of the things is these are other services that I've defined in this project. It's a simple injection mechanism, which is just a simple IOC implemented here. I'm able to pull in, these services are implemented here. So validate is just a very simple one function thing again. In the create to do, I am simply just referencing them, pulling into the function, and request them and require them. That's what we do. And then we are able to invoke. So I totally spared how and where the other service is living, what's the name, how to invoke it. I'm just requesting it, and the system, based on the configuration and the actual setup, will provide me with some very easy way to invoke the service. I don't have to know if it's behind the HTTP thing, if it's behind messaging, whatever. So it just puts everything into my hand without a big effort. Another such an example, so these are actually services talking to services. I will show in a couple of minutes. The very same way, we can actually do it with other system primitives. So what we here have injected is a to-do table, is actually a dynamo table, but all we said is so here is where we defined, that's all. We just define a table entity. There's no logic in it because the implementation of it is actually online. We just need something to reference. And then, with that effort, we can just reference the thing here and call it. What we did in the background, and that's the small magic, is we intercepting these decorators, and we just do a little pre-processing. Everything is like just collecting the correct information into one piece, and actually providing all this information for the invoker code on a very simplified way. So what I will do now is just deploy the thing to online. So that actually we can see it builds up stuff and puts them online just from the actual definition. So it actually realized there's no to-do table, so it created one and deployed my functions. So if I get back to AWS, then I'm already having here a number of functions. They're all there. And now I'm able to invoke it. So what I'm doing is another little trick. I created a load script which actually invokes this service quite often. And the service is very, very dumb. What it does is inserts a to-do item to a to-do database, a to-do table, but also calls validate, which will pass now every time. What I will do is just make a little bit harder for the to-dos to get there. So actually every second time a to-do item will be invalid. So what we do here is just just rebuild and redeploy while the whole application is running in parallel. And if it's all well, then without a real outage, we started to get errors. This error is about the to-do has been rejected, not every time, but every second time. And this whole thing happened without a downtime. So what happened is I just upgraded the application. I didn't really do anything. I didn't put effort in high availability on that sense or graceful rollovers or whatever. I just deployed a function. Because of the nature of the functional framework, it just works. Right. And actually, pretty much this was my session. So thank you. A little bit longer than expected. Sorry for that. What we did, just really as a summary, is like, well, this is like 20, 15, like let's say 100 lines of code. We really implemented a sort of complicated service with many interactions between the service functions. So they are actually invoking each other. They are writing into the database, whatever. And we have an auto-scaling system which scales up really as the load arrives, which we are able to actually deploy gracefully anytime. And this cost us really no time because the serverless infrastructure was providing most of the things. The little magic here was that we didn't need this sort of huge complex configuration because we can express everything in code. All right, thank you guys.